Put on some mood lighting. Do I have any candles? Sorry. So this first one, you don't have to graph anything, but what's the only way where you really have to determine if something's 1-to-1 right now? What test? Horizontal line test. You don't have to graph these, but if I did graph this, it would be a diagonal line, correct? 2x minus 1? And that definitely passes the horizontal line test. So that's a good one. Cube roots. Cube roots. We haven't actually talked about cube roots, but a square root basically looks like this, right? Why does it stop at 0? Why doesn't it keep going?
It's nothing good.
Second?
A square root can't have a negative.
Good. Square root can't have negatives. What about a cube root?
Okay.
What's the cube root of -8?
2.
-2. Right? So when I raise something to an odd power, its sign stays the same. Yes? So if I raise a negative number to an odd power, it comes out negative. Therefore, cube roots can handle negatives. Why can't square roots handle negatives? Because when I square any real number, it comes out positive. So how can a square root undo a negative thing? It can't. Unless you bring in complex numbers. No, we're not going to do that at the moment. A cube root, like we just said, the cube root of -8 is -2. So a cube root kind of keeps going. Maybe. So would that pass, and again, you didn't have to graph this, but would that pass the horizontal line test? Does it? Yes, it does, totally. So that one's good. Check. And this one's a quick one. What would that look like?
Parabola.
Whoa, holy crap. A parabola. And does a parabola pass the Holt? No. So that one's a no-go. So that's nice. You're like, oh good. One of these I don't have to worry about. I am going to talk a little bit more about this one though. We are going to get an inverse somehow. So F and G pass horizontal line test. That is the word pass. That's what that is. Yes. So I can find the inverse for f of x. So let's write, here's f of x. Y equals 2x minus 1. And what's the procedure I use to find the inverse?
Substitute y for x.
Say again?
Substitute y for x.
Yeah, switch x and y, right? I love it. Same way we do the graph, right? It's kind of nice, the same idea no matter what. So I switch x and y, good Lord, Jeff. And then I solve for y. So f inverse. Is that cool? I just did that quick. Add 1, divide by 2. Is that smart? And I can find for h of x, y is the cube root 1 minus x. So I switch x and y. How do I solve this thing?
Cube both sides.
Cube both sides to kill that cube root. I love it. That cube root. And then here's one of the coolest little tricks in algebra. If I add the y, subtract the x cubed, see how this and this just switch places?
Mm-hmm.
Okay. Maybe? Or you go through all the steps and you get there eventually. Right? Is that all right? You guys okay? Yes?
Would it be improper notation to write -x cubed plus 1?
No, it's not. But I will put one more step here. It should be h inverse. There we go, Jeff. H inverse is 1 minus x cubed. And -x cubed plus 1, same thing. Yeah. I like it. It's just math people, we don't like it because it takes a little extra writing, and all math people are pretty lazy. Yes?
2 comments in a row. I think that's g inverse. H inverse.
Why did I put H? Thank you. So this is G. We'll talk about, I had G and H in the brain. We are going to do something with H. I promise. In fact, no, let's come back to that. Okay. So is that cool? G inverse, not too bad, right? Okay, and again, it really makes almost too much sense. If I want to find the inverse, when I switch x and y and solve for y, I'm going to undo all the operations. So of course it's going to build the opposite function. Now, I do want to do one really funky one. What if I had this function? So let's go through the steps to find the inverse, right? So y equals 1 over x. How do I find the inverse?
Flipping.
Switch the x and y. And then I have to solve for y. How do you solve that for y? The worst problem is, where's the variable I'm trying to solve for? It's on the bottom of the fraction, correct? I don't want it on the bottom, so what can I do immediately? I don't want the y down there. That's I'm trying to solve for it. I want to get that bad boy up. How do I cancel it out of the bottom? What do I do to both sides? Multiply by y, yes. If I multiply both sides by y, die. And then how do I solve for y?
Divide by x.
Sorry. I'm very violent in mathematics, I know. So what do you notice that's interesting? If f of x is 1 over x, f inverse is 1 over x. Does that make sense?
No.
If I flip a number, no, listen. Give me a number.
2.
2. What do you get when you flip that number? Flip it. 1 over 2, right? 1/2. How do I undo that? I flip it again. So what does 1 over a number mean? It means flip it. Are you guys with me? No? Are you guys okay? So if this is the function, f of 2 would be 1 over 2. Yes? What is f of 1/2? 1 over. You can do it. Just play. Right? What's f of 1/2?
1 over
1
1
over
half.
x.
1 over 1/2. And how do you do this division? How do you divide by a fraction? Multiply by the reciprocal. So you get back to 2. So sure enough, f of 2 is 1/2. F of 1/2, of course, comes back to 2, because if the function says flip it, how do you undo that? Flip it again. So of course it's its own inverse. Now going in, we might not be a lot like courses and all, but once we do it, we're like, holy shit, the function and the inverse are the same thing. And you go, why does that make sense? Because how do you undo a flip? You flip it back. Now let me ask you this. What does that mean about the graph of this? Because graphically, how do we find the inverse? Don't we just take all the points and change the x and y? Yes? All right, let me come back to that question. Let's do this one, and then I'll come back to that question. How do I find graphically the inverse for this function?
You just switch x and y.
Yeah, so let me do it the full way. If I make xy table for what it currently is, I'll have -10, -7, right? I think that is? Yes. And -5, 0. I think that is. And 5, 5. And 7, 10, it looks like. Is that right? 7 and 10, yes. Another little antidote up there. Are you guys with me? So just collecting what points are there already. So how do I make a list of all the inverse points?
Switching.
Switch x and y. So the inverse has to go through -7, -10, 0, -5, 5, 5, that was a nice one, 10, 7. So -7, -10. Be awesome if I could see, there we go. Let me zoom out just a little bit. -7, -10, 0, -5, 5, 5, and 10, 7. So why does that look correct visually?
It's symmetrical along y equals x.
So can anybody figure out what would have to be true about a function? Is that cool by itself, that problem? That should be like a, oh Jeff, give me a lot of those problems. All I gotta do is flip the points around, regraph it, what to do, and I know how to tell if it looks right. What would have to be true about the graph of a function that is its own inverse. That means if I flip it around the y equals x line, it would have to line right back up with itself. So it would have to already be symmetrical. So watch, I don't know if you guys know, what does 1 over x look like if I graph it? Does anyone know? You do? What's it look like? Yeah, you got. I know what you're trying to do. I love it. Okay. So real quick, x, y. If I put a 2 in, I get 1/2, correct? If I put a 1 in, I get 1. That's crazy. If I put a 1/2 in, I get 2, like we just got a minute ago. You guys with me?
Mm-hmm.
What if I put a 1/10 in?
10.
10. What if I put a 100th in?
100.
100. Holy shit. Right? And then all the negatives also. So if I put in there a -2, I get -1/2 and so forth. Is that cool? If I put negative numbers in, I just get the negative outputs, right? So look what this looks like. 2 is 1/2. 1 is 1. 1/10 is 10. So it looks like this. Whee! This is an asymptote. Oh shit. And then it's basically all the negative stuff just reflects down there. Isn't that symmetric already to y equals x? So when I flip it, when I flip the graph, it perfectly lines back up with itself. So that's graphically why I would expect it to be its own inverse. Does that make any sense? Are you guys? Okay. All right, so I got a lot out of that problem. What about number 3? Is just listing the transforms. That needs to be, oh my gosh, something that's not too crazy. What's technically the first thing I should do?
Left 1.
Left 1, good. Work from the inside up. Left 1. Then next I should
Double outputs.
double the outputs.
Down 5.
Down 5. Are we all over the fact now that if it's in with the x, you do the opposite? I think I've really hit that hard. I want it to make sense. I don't want you just to memorize that. I want it to make sense why. So whenever I ask you to use transforms, you have to graph the base graph, right? So 0, 0, 1, 1, 2, 2, -1, -1, 2, -2, 2, blah, blah, blah. So my base graph is just an absolute value. So now I just take a point, I move it left 1, double the output, so the output's 2, so now it's going to be 4. And then I move down 5. 1, 2, 3, 4, 5. Pick the next point, left 1, double the output. 1, 2, 3, 4, 5. Left 1, double the output. 1, 2, 3, 4, 5. And then the cool thing is, this graph is symmetric, right? So there should be a point there, and there should be a point 1, 2, 3. I'm sorry, 1, 2, 1, 2. So definitely move down, and it's hard to see here, but it's definitely skinnier. Are you guys okay out there? Is that how do you feel about transformations? I mean, if I throw a lot of transformations in, that sucks. But if each transformation, hopefully at this point, is not too evil. Yes.
Would you call that shrinking? Or
it would be a vertical stretch.
Okay.
And remember, see how you can take the 2 inside? If I take this, a V, and I smush it, right? Compress it in the horizontal direction. Isn't that making it stretch in the vertical direction? That's why if I put a 2 in, it cuts the inputs in half. If I take it out where it is, it doubles the outputs. Both of those do the same thing. They end up smushing it or stretching it. They're the same. I really want that. We saw that yesterday, I think, where I took something out. Yeah. Maybe, is that all right, you guys? I'm going to stop trying to read most of you. Okay. Now, coming back to this guy. X squared minus 1. Let's focus on him for a minute. Can anybody tell me about anything about this graph? We've already said one thing, so you can say it again if you want to. Tell me anything about this graph. It's going to have points. Yes. Tell me anything about this graph.
It goes down one.
Goes down one. And what is the shape that you're moving down one? Parabola. I love it. So it is going to be, goes through 0, 0, negative 1, 1, 1, 1. So it's a curvy dude, right? It's not a, so it's a curvy dude. This would just push every point down 1, right? Down 1, down 1, down 1. So here's where it is. And you can see visually, you can see why this thing doesn't have an inverse. It doesn't pass the horizontal line test. What's the domain of this thing at the moment? What's the domain of this? You guys can do this. All real numbers. There's no, or what were you about to say? I'm sorry. Negative infinity to infinity. I love it. Same way to say all real numbers. I love it. Right? Because there's no number I can't square. And then there's no thing I can square it, and then I can't subtract 1 from it. So any number works. Is that cool? What if I restrict the domain? Can you restrict the domain so that what's left passes the horizontal line test? Can you erase part of this graph so that it will pass the horizontal line test? Yes. Where does it start to not? Like if I look on this side, everything's cool, right? This side, everything's cool until, shit! Now it doesn't pass. So could I just, if I could just erase everything back here. So if I restrict the domain, I do end up with the function I can take the inverse of. How do I have to restrict the domain? I need to have x has to be what? To erase this backside. What's the first input I want to use if I want to erase all this? 0. If I start here and go, doesn't that pass the horizontal line test? If I could just erase this. And now, I know, you guys are like, I can just erase it? No, don't get too excited. We're talking what would have had to have been given to me so that this would be invertible. They would have had to tell me this. Because now the picture would have looked like this. Sorry. What's up, sir?
What?
Say again?
Sales are going up.
Still going up?
Sales?
Sales are going up.
Oh! Okay. Is that all right? So now, think about this. What's the inverse now? Well, let's see if you guys, how do I find the inverse? Here's this, right? Yes?
Mm-hmm.
Oh, I'm sorry. It should be down 1. Is that what you're trying to tell me? This was the original. Dadgummit, Jeff. This one, not this one. So this one, right? So this is definitely passes the horizontal line test. How do I find the inverse? I switch the x and y. How do I solve that for y? You add 1. Now normally when you take a square root, what do you have to put? Plus or minus. But look how we're taking just the positive side.
Mm-hmm.
So this will be y equals square root of x plus 1. I don't have to put a plus or minus. So is there one output for every input? Yes. Is there? Maybe. Are you guys semi with me? So this is going to come up big time in trigonometry. Oh shit. Right? So I just want to lay the groundwork right now. You can actually take a function that is not invertible and just say, I'm only going to use these x's, and all of a sudden it's invertible. So what about a circle? Does anyone know what the equation of a circle of radius 1 is? Yeah! Just the Pythagorean theorem, Jeff, really? Every point on this circle has to meet Pythagorean theorem. Is that invertible? Is that 1 to 1?
Mm-mm.
Hell no. But what can I do? I can try to chop off this, right? Wouldn't that be a function? Well, no, not that. What am I talking about? I'd have to chop off, oh God, I'm too close to this thing. I'd have to chop off all of this so that this would be a function and it's invertible. Because right now, is that even a function?
No.
No. So if I could just chop off this piece, and this piece, wouldn't that be a function then, that little piece? So if I just looked at the part in what we call the first quadrant, if I just looked at this part, is that a function?
Yes.
Is that invertible?
Yes.
Yes. You guys kind of get the idea? So if I am given a function and it's not invertible, I can restrict the domain until I make it something I can invert. This guy was even worse. He's not even a freaking function in the first place, right? Maybe? If I chop off just the bottom, is that a function now?
No.
Am I not? Is that a function?
Oh,
Not
yes,
one.
yes,
Is that
yes,
a function?
yes.
Because it passes the vertical line test. Is it 1 to 1? No, because it doesn't pass the horizontal. That's why I have to chop that and that. So I get this, and that is both. That is both a function and it's invertible. Crazy shit. Okay. Maybe?
What type of function doesn't pass the vertical line test?
Oh, well, all right. It's a really neat question. That's sort of like, what kind of a bachelor is married? So if you don't pass the vertical line test, are you a function? No. If you are a function, do you pass the vertical line test? Yes. So there is no function that doesn't pass the vertical line test.
Okay.
By definition, do you see what I'm saying?
Yeah.
Okay.
Just keep it to that.
I like it. All right. Okay. Enough of this one. I don't know how you're gonna feel about this. All right. Yeah, it's just the way it's gonna be. So if you really hated doing the group work a minute ago, great news. You're gonna do some more. We're about to get into chapter 4, but I just want to give you a little worksheet that's got some graphing basics, just to kind of see where everybody is with what they already know. You with me? So there could possibly be some stuff on here that you're not sure how to do.